When people hear supervolcano and ring of fire in the same sentence, the imagination tends to jump straight to a cinematic nightmare. One colossal eruption, then another, racing around the Pacific until the planet is swallowed in ash and fire. It is a gripping image. But current science does not support that scenario. The more credible danger is both less dramatic and, in some ways, more serious. Not a planetary eruption chain, but one major eruption causing severe atmospheric disruption, agricultural losses, transport breakdowns, economic shocks, and political strain across a deeply interconnected world. To understand this properly, it helps to separate three categories that public discussion often mixes together: what is well established, what counts as a realistic worst case, and what remains speculation. First, the well-established part. The Pacific Ring of Fire is not one shared magma chamber, and it is not a continuous underground fuse waiting to burn all at once. According to the Smithsonian Global Volcanism Program, it is a vast belt of numerous volcanoes and earthquake zones associated with plate boundaries. In plain terms, it is a region shaped by many different subduction zones, fault systems, and volcanic centers, not a single machine with one on switch. That matters, because if the structure is not unified, then the idea of automatic global cascading failure becomes much weaker from the start. Volcanoes do not erupt simply because another volcano, far away, has erupted. Most need long-developing internal conditions before an eruption is even possible. Enough melt, enough pressure, the right amount of dissolved gas, fractures that allow movement, suitable geometry in the plumbing system, continuing magma supply, and often measurable deformation. An outside event may sometimes nudge a system that is already highly primed. It does not usually create that readiness from nothing. There is some qualified counter-evidence here, and it is important not to overstate the case. The USGS does say that eruptions or major tectonic events can sometimes influence other volcanoes. But the key point is scale. These interactions are mainly local, regional, or limited to tightly coupled systems. A nearby or sensitive volcano may respond to stress changes, magma movement, fluids or earthquakes with increased seismicity, shifts in gas output, or in rare cases, an eruption. That is real geophysics. But it is not evidence for an automatic, planet-spanning chain across the Ring of Fire. So the core claim can be stated clearly. There is no solid evidence that one super eruption would automatically trigger distant eruptions around the Pacific. The idea of a planetary domino chain remains unsupported by modern geoscience. Part of the confusion comes from language. People often treat large eruption, caldera eruption, high VEI eruption, and super eruption as if they all mean the same thing. They do not. Those labels describe different things, and the climate effects of large eruptions are not interchangeable either. A very powerful eruption can be globally disruptive without being a super eruption. A caldera-forming event is not automatically the same as the most extreme category. And volcanic explosivity does not map neatly onto one simple outcome for climate or civilization. History gives us useful anchors here. Tambora in 1815 is linked to the year without a summer, a stark reminder that one eruption can alter weather patterns and damage food production on a wide scale. Krakatau in 1883 is remembered for its huge explosion, tsunamis, and atmospheric effects. Pinatubo in 1991 is especially important because it gave scientists direct observations of sulfur dioxide reaching the stratosphere, forming sulfate aerosols, and cooling the climate. Toba, roughly 74,000 years ago, is often invoked in apocalyptic arguments, but many of the most sweeping claims around it remain debated. That historical record supports a serious warning, but not the most extreme version of it. Yes, eruptions can affect climate. Yes, sulfur dioxide in the stratosphere can drive cooling. Pinatubo is the clearest modern model for that. But NASA-referenced modeling suggests that even very large super-eruptions may not automatically produce decades-long, near-uninhabitable global freezing. So again, the strongest disaster claims go beyond what the evidence firmly supports. Yellowstone is often pulled into these discussions, usually with deadline-style claims that it is overdue. The USGS says that is misleading. Eruption intervals there are not regular, so the idea of a ticking geological schedule does not hold up. Based on public USGS data and Smithsonian summaries, Yellowstone is active and closely monitored, but there is no robust sign that it is on the verge of a supereruption. That is only a snapshot, not a guarantee about the future, but it is the evidence-based snapshot we have. And Yellowstone is also a good example of why source criticism matters. Public conversation often runs on viral graphics, repeated myths, and dramatic certainty. Scientific institutions tend to speak more cautiously because volcanoes are complex and the limits of knowledge are real. The careful position is usually less exciting, but it is also more trustworthy. Now to the realistic worst case. If the global eruption chain is speculative, what should actually worry us? The best established physical hazards from one major eruption are already devastating enough. Near the volcano, pyroclastic flows can obliterate everything in their path. Ash can collapse roofs, contaminate water, damage power systems, shut down engines, ruin fields, and cripple cities. Lahars, the fast-moving volcanic mudflows that can surge down valleys, can keep destroying landscapes and infrastructure long after the main eruption ends. These are not fringe scenarios. They are among the most direct and lethal volcanic hazards known. Then come the wider consequences. A very large eruption in a densely populated, agriculturally important, logistically critical, or politically fragile region could produce years of crop loss, rising prices, trade disruption, and political stress. Aviation could be heavily affected by ash. Health systems could be strained by respiratory illness and contaminated water. Supply chains already stretched by modern dependence on just-in-time delivery could seize up. Financial markets would not need the end of civilization to panic. This is where the realistic worst case becomes global. Not because volcanoes everywhere erupt in sequence, but because one immense event hits a world of dense cities, fragile infrastructure, concentrated food production, and tightly connected trade routes. In that situation, a single eruption could trigger a global supply crisis. There is also an active research uncertainty worth taking seriously without exaggerating it. A more serious open question is whether a very large event could slightly alter the odds of unrest in other sensitive volcanic systems. Distant effects through dynamic stress changes are plausible in some cases. Scientists do investigate whether seismic waves or stress perturbations can influence already unstable systems. But plausible is not the same as proven, and it is not evidence for a global eruption chain. At most, this sits in the category of limited influence on already sensitive volcanoes, not a synchronized Pacific-wide ignition. Monitoring is another place where nuance matters. Volcanoes often show warning signs: earthquake swarms, ground deformation, changes in gas output, shifts in heat flow, and changes in water chemistry. The USGS emphasizes multi-method monitoring for exactly this reason. But warning times vary enormously. They can range from years to days, and unrest does not always end in eruption. So monitoring improves our chances of understanding what a volcano is doing, but it does not turn volcanic forecasting into a precise countdown. Put all this together, and the balance becomes clearer. Well established. Major eruptions can seriously disrupt climate, aviation, health, water supplies, agriculture, and economies. They can devastate regions directly and stress the whole world indirectly. Realistic worst case. One very large eruption in the wrong place at the wrong time could trigger years of agricultural damage, transport disruption, price shocks, trade problems, and political strain on a global scale. Speculation. One supervolcano igniting the entire ring of fire in a single civilization-ending cascade. That last image is powerful because it compresses many real fears into one simple story. But simple stories are not always good science. The Ring of Fire is a belt of many systems, not one reservoir. Volcanoes usually need long internal preparation. External triggering appears limited, conditional, and mostly local or regional. And while there is real uncertainty in volcanology, uncertainty does not automatically support the most extreme conclusion. So, is a global eruption chain looming? On present evidence, no. A planetary domino effect around the Ring of Fire is not supported. But that should not make us casual. Humanity would probably survive even an immense eruption. The danger is not instant extinction by geological chain reaction. The danger is that one truly major eruption could still darken skies, damage harvests, disrupt transport, stress governments, and expose how fragile the modern world really is. Subscribe, enable notifications, and suggest the next topic in the comments.